For this one here, the table to the right gives the size and distance data for planets at a certain point in time. Calculate the scale, size, and distance for each planet. Use the 1 to 10 billion scale on the solar system. So they give us a table here. What we end up doing, find the scale, size, and diameter of Mercury. So 10 billion is the same thing as 10 to the 10th, or 1 with 10 zeros behind it. So find the scale size. I divide it by 1 billion here, and it gives me this number here. A very small number in kilometers. It doesn't mean much distance-wise, so we'll go ahead and convert it into millimeters. So when I converting it to millimeters, I can just shift the decimal point. So how many jumps does it take to get from kilometers to millimeters? 1, 2, 3, 4, 5, 6. So I shift my decimal point the same number of places. 1, 2, 3, 4, 5, 6. So I end up with 0.49 millimeters, or round it to 0.5 millimeters there. So that is the scale diameter. And then they do the same thing again to find the scale distance from the sun. So they have, I divided by the scale size there, 10 billion. 10 billion is the same thing as 1 with 10 zeros behind it. That's what I do there. And I simplify it a little bit. And I get it down to where it's 69.9 over 10,000 here. And as a decimal, I get 0.0069 kilometers. It may not mean much in kilometers, so we can convert it into meters. So convert it to meters. So I kept the number of jumps it takes to get from kilometers to meters. 1, 2, 3. 1, 2, 3. 3 jumps. So I shift my decimal point 3 places, and I get 6.9 meters. And that gives me the scale distance from the sun. We end up repeating that for each one of those. And our table looks something like this. And that's all there is to it.